Thanks, Stephen. Thanks, Omar, for inviting me. So the last session was actually a really nice setup for this next talk. So let me just give a little bit of background about my perspective here. So my name is Shaikh. I'm with the network architecture team at in Google in the network operations area, part of technical infrastructure overall. So this material was put together by myself and my colleague in network architecture, Josh George, but we're here not just representing Google network operations, but also a broader set of partners that we've been working with in the industry to try to help move the state of management forward. And as I said, the sort of discussion that Matt led in the last session was a really useful setup for this. I think we haven't solved all the problems that we enumerated, but we're trying to make some progress on a few of them. So I will be talking about sort of an outward-facing effort. This isn't really about Google's own infrastructure so much as it is about what we're trying to do to help move the industry forward along with a bunch of other partners in the industry. So, of course, it's motivated by a bunch of problems that we and other large network operators have, right? So in our network, we have over 20 different device roles that are doing lots of different things. We have more than half a dozen vendors. We have all the problems of multi-vendor heterogeneous networks, multiple platforms from those multiple vendors, multiple generations in some cases from those multiple platforms from multiple vendors. So the space sort of really starts to get complex. Lots and lots of configuration that we're managing and lots of churn in the configuration. It's fairly dynamic even for us as primarily running IP infrastructure. We don't have a lot of subscriber services the way other telcos do, but the dynamism in just our infrastructure is pretty significant. So we do, for example, up to 30,000 configuration changes every month. We have a very large number of voids that we scrape. As you might imagine, lots of CLI scraping that we're doing to get data off of our devices so that we can reason about what's going on in the network. And of course, as you might imagine, at Google, we have a few software developers around. So we've got a lot of tools, multiple generations of tools, software that is not ready for production, but still other software that it's meant to replace hasn't been fully deprecated. So we have things sort of some complexity in how we deploy things all the time. We're trying to always improve while still not fully being able to get rid of what we currently are running. So there's a good deal of complexity in the network. Now, I think what operators like us and others would like to get to, and I think we talked a little bit about this last time, so I'll reinforce some of those things. One of them is just around visibility in the network. And to do that, we need a much more scalable, real-time version of monitoring. We rely on monitoring and telemetry to do all of our traffic control loops and traffic management in the network. And we're trying to move from a pull model to a push model. We don't want to scrape SNMP voids anymore. We want to actually have devices send data to us, and I'll tell you more about what we're doing there. And also, as Matt also described, this notion of publish subscribe is extremely important. I want to be able to specify the data that I need to get, that I'm interested in seeing, and I want to be able to change those subscriptions dynamically, because sometimes there are cases when I need to look at something more specific. We're also trying to move away from sort of this imperative style of doing configuration management that we've been used to a more declarative style. I want operators to be able to specify what they want the network to look like, not how it needs to happen to get to that end state. And moreover, we need abstractions. So yes, having access to low-level stuff is important when it's needed, but in general, we need abstractions to manage the complexity of these networks. As we start running more services, more classes of service, the networks grow, the amount of traffic is growing constantly. The network keeps evolving. We need a way to manage the complexity. One of the biggest problems we have is in quals, right? So we're trying to qualify new technology to go in the network. These qualification cycles are extremely long, and a lot of it is because of all the integration that we need to do with our existing tooling. So we can't deploy anything into the network until we know that it works with our alert systems, with our monitoring systems, with our configuration systems, with all the other things that we need to work in our ecosystem. And no operator in their right mind is going to deploy something into production without making sure all those things are fully qualified, right, against their tools. So that takes a long time when you have to qualify every different device or every different software technology differently. We also want to get away from scripting and sort of leverage software platforms on which our network engineers who are rapidly becoming software engineers in addition to network engineers can start writing actual tools on those platforms. So we want to increase the number of software skills. I think we talked about this a little bit. Fewer people who are just CLI jockeys and are more thinking about software that they can build to get the job done that they need to do. And then safety is a big issue. Operations that are policy compliant. I won't talk a lot about this today, but a way to scope the blast radius of configuration changes, for example, a way to make sure safety checks are built into the configuration pipeline so that when we deploy new configurations, for example, we can be sure that, first of all, if they're damaging, they don't damage a lot of the network at once, and second, we do everything that we can to make sure that they aren't in fact damaging. So I think we talked about this, so I won't spend a lot of time on this. I mean, there's a bunch of issues that are holding us back from this, right? So I think we're living in a world where we're still doing lots of proprietary integration. So we talked a little bit about CLI and SNMP. So even with these automation frameworks that we have, we're still doing proprietary integrations. Maybe in some cases we have modules or minions or cookbooks from somebody who's built those, but at the end of the day, they're really just fast typing machines. So it helps me do the automation, but it doesn't get away from needing to do all those proprietary integrations. Lack of abstractions, we talked about a little bit. CLI scraping, where we're getting unstructured data back. What we really need is structured data. SNMP monitoring, I'll say more about issues with this in terms of poor scaling, the inability to extend it, all the proprietary and enterprise MIBs that we have to deal with. And I guess the bottom line here is that a lot of this complexity and cost, and please, I guess I'm sort of preaching to the choir here, but feel free to disagree with me. A lot of this complexity and cost has been pushed to operators, right? So operators have to manage all of these proprietary integrations that we need to do with all the devices. So that's why we have these long qualification processes. That's why we need to have specialized skills in our shops that know the ins and outs of a particular vendor's gear, and then we have another set of folks who may know the ins and outs of a different vendor's gear. So we're trying to develop some approaches that will help us get away from some of that.
Elise, can I ask you a quick question there?
Sure.
How many of these issues would you say are applicable to all parts of the infrastructure? So, stuff that you might have learned that the storage guys could deal with, the server guys could deal with, and vice versa?
Yeah, great point. I think we're trying to learn a lot of the lessons that we have in how we manage the rest of our infrastructure, compute and storage and application in particular, and try to bring it to networking. In networking, though, we're a bit hamstrung by some of the technologies that we have. And so this is an attempt to try to bring some of what we have in networking in line with what we're able to do today with compute and storage. But yes, I mean, we're definitely trying to apply those lessons. In particular, if you've seen some of the talks that Amin Vadat has given, who's the ATL for networking at Google, he talks a lot about bringing those lessons, especially into how we manage our data center fabrics. All right, so here primarily we're talking about where we have a lot of vendor gear, which is primarily in our backbone.
Do you think the bigger problem here is the interface to the device, or how the data is modeled on the device and returned back to you?
So I think it's both. And we're actually trying to tackle both problems, as hopefully you'll see. So we're trying to tackle the problem of how the data is modeled on the device, because that needs to be normalized, and also the way we access data off of the device. I mean, the problem with this pole-based mechanism is that it just will not scale. If you're trying to deploy some of the newest gear from vendors, very high scale, high density, and you have to do any sort of discoverability on those, walking MIBs and so on, your device will melt.
Do you view the device as, let's say, publishing data as part of what you're covering today, as part of OpenConfig?
Yes, to the extent that we want that to be model driven also, right? And so OpenConfig isn't necessarily about configuration. It may be, in retrospect, misnamed in that sense, but it's really about the data models. And the data models are applicable not only to configuration, but we're arguing that they're also applicable to telemetry. So that brings us to the value, what we think the value of data models is. I mean, a few things that I think that data models provide us, right? They give us these durable APIs, right? So the data model is essentially the definition of the API that we have for managing the device from a configuration perspective as well as for monitoring. It gives us the equivalent of sort of a hardware abstraction layer for management or for configuration, right? It gives us a way to insulate operators and tools from the low-level details of a particular vendor's device, right? So it gives us that layer of indirection. It helps us with qualification, because new devices, as they roll into the environment, if they follow the same data model, it means that all the qualification and integration work we need to do with our existing tools gets that much simpler, right? Because we're not building a whole set of extensions or drivers for the next device that we're trying to roll out. And then it gives us something that we've never had before, which is really a contract between the management system and the infrastructure, right? That is clear in terms of, if I change the version of the data model, in a way, it's a clear indication. In a certain way, it's a clear indication that that API is now backward incompatible, or I change it in a way that is compatible with my current tooling. So if I adopt something like semantic versioning for these data models, I have a clear contract that says, if I've written tooling against this version of the data model, I can be sure that if the major version hasn't changed, my tooling will continue to work. Whereas if the major version has changed, it means I need to continue using the old version of the data model or upgrade my tooling, right? So it's just like we do everything else in software today. Right? We haven't had that in the case of infrastructure management. And so what we're doing in OpenConfig is trying to focus on defining some of these data models, right? By leveraging interest in this across the industry, and also trying to really focus on vendor neutrality. So I think there was some discussion earlier about, if I could get a set of APIs or interfaces that would work across my entire environment, no matter what vendor it was, that would help me solve a lot of my problems, or at least simplify some of my problems. And I think that's one of the goals that we have here with OpenConfig. So today, we're kind of what I would call the dark ages, right? We're still living in a world where we're doing lots of proprietary integration. So, we're either writing to vendor NMS tools or EMS tools, or we're, scripting CLIs that are different for every single device. Requires lots of platform-specific tools, as we talked about, lots of platform-specific processes, which introduces more problems, and platform-specific skills. Now, I think we're starting to get to a point where we're starting to build these layers where we are supporting a northbound interface that's common, but we're still doing that proprietary integration under the hood. And there's third-party providers that provide. I think somebody mentioned TailF. They're an example of this, where they will hide all the gory problems and details of doing this device-level integrations and give you an interface up top. But at the end of the day, you're either beholden to that third-party provider, or you end up writing these drivers yourself and providing your own indirection layer. So you haven't really gotten rid of that part of the work yet. So where we're trying to get to is this world, right, where we have a common management model that allows us to both configure and monitor devices using data that's expressed and structured the same way across all the different vendors that we want to support. So common management APIs gets us away from proprietary integrations. What's key for this to work is that there has to be native support for these models on devices. So it's no longer the job of the operator or the module or cookbook or minion writer to go and write these integrations. It is the job of the vendor to support this externally defined data model that provides a common management API.
Yeah, I thought I heard you say, it might have been the Open Daylight when you recently, maybe a few months back, that you don't care what the API is. If vendor A wants to use NETCONF, go for it. If they want to use something else, go for it, as long as it's modeled correctly. So, is that accurate? Because when I see this slide, I read at a unified API supported on multiple vendors, not just the data model itself.
So if you consider the API both the transport as well as the data model, then I would say we care about the data model a lot more than we do about the transport, right? The data model, to me, is what really defines the API, right? That's the data, what the types are, what the structure is. Sure. But the transport could be, how I serialize and transport that data. Could be NetConf, could be RESTconf, could be JSON RPC, could be gRPC. So we have our preference at Google. I think other operators have their preferences. I think what I had said before in other places was that in OpenConfig with this group of operators, we haven't sort of decided to say this is going to be the standard transport that everyone should follow, because different operators have different environments with different needs, right? So what we are saying is that we're insisting that the model be the same.
Got it. I think it's worth mentioning also that regardless of which model, that translation between what is specific to a vendor and what is generic is going to happen somewhere. And I love how you broke it out like this, because it's going to happen regardless. But I think it's important to note that on the right, that translation is being moved all the way out to the edge, where it's, I guess, most effective, most scalable.
It's actually a good point, and you're reminding me of another thing that one of my colleagues asked me to point out here, was that even if we define this common management model and we don't have full native support on day one, and we're not going to have that, right? If we define that layer, it's still useful to define this, right? So all the northbound tooling can use that layer. So now if I'm writing, that same colleague's favorite example is, I'm writing configuration, for example, for my web servers across my environment. I've got Nginx, I've got Apache, I've got a bunch of other things, right? If I can define a common way of managing and configuring that, then all my tooling can use that But then underneath, I'm writing the drivers, but maybe as the native support starts showing up, those drivers and the maintenance associated with them starts to disappear. So how do we use these models? I mean, this is always a question that comes up. I mean, the way that we've been thinking about how the models are used is sort of as follows. This is kind of just a bit of a stylized example, but I think you'll get the idea. So we're trying to provide an intent-based API for network operators, right? So they might express a high-level intent. It's not meant to be the push the button and watch it all happen kind of thing exactly, but it is meant to be an abstraction, right? Where you can do something like you want to drain a particular peering link because of some issue. That may translate into an update to a topology model. So I haven't talked a lot about topology models, but that's also clearly a part of a model-based network management stack, right? So everyone has a topology model. And that update to the topology model can drive then generation of configuration, right? So I've removed this peering link from the topology model. That means I've got to update my BGP sessions, or I've got to change the policy on that session to start driving traffic away from that link. And this is where the models come in. So the models allow us to generate that configuration in one way, right? In one way, and validate it also in one way. So at the bottom of this stack, what comes out is an instance of configuration data that's vendor neutral, and it's validated against the model. And then the vision is that we can send that to all of the devices that are involved, no matter what vendor they are, right? And we are, as I said, trying to push the industry to adopt gRPC. We think it has a lot of advantages, which I can talk about later, as a transport mechanism. But the transport doesn't really matter. I mean, what matters is that this configuration data will work. You can send it as is to every vendor device that you have. So let's turn our attention to telemetry a little bit. I know Stephen didn't want to talk about SNMP, but we can't help ourselves because we love it so much. There's a bunch of issues that we've run into with SNMP, and I know that we're not alone here. I think operators in general are looking for another solution to this problem of monitoring, right? So one is, of course, just the legacy implementations. These implementations haven't been touched for a long time. They're very brittle. We've had major outages due to SNMP implementation issues. Discoverability is expensive. Having to rewalk MIBs just to discover that a new interface or line card or BGP session or LSP has been added is an expensive operation. There's no way to figure out what OIDs are actually supported on the device. Very rigid, no way to extend them easily. Everyone ends up stuck with enterprise MIBs. That means the exact same data for a BGP session from one device and the data from another device actually comes on different OIDs with different names and looks different and is structured different. It again brings us back to this problem of proprietary integration. And then there's really no way to update how that data is delivered, right? So we're also stuck with the protocol that SNMP provides. So what we're trying to move to is a streaming telemetry model, and I think you'll see this more and more in other places. I think we've done this in a lot of other parts of infrastructure already. Networking is a place that I think we're still behind, where we have a set of telemetry collectors, and then we want to send data, have it pushed as a time series continuous stream from devices, right? So I can get, for example, interface counters on a constant stream. They're sampled every 10 seconds or 5 seconds, and they're sent up to the collector. Also, I want to be able to get asynchronous events. Something changed on the device, whether it's a configuration change I think we talked about, or some triggered event happens, I want to get a notification asynchronously from the device. And again, that's pushed to the collector. And then finally, we'll always have the need for requesting some ad hoc data from the device, the equivalent of a show command, but using structure as opposed to send a CLI command and then come back and parse the data that is returned. And then the other problem that we have is, as we introduce this technology in our environment, we have a bunch of upstream systems, every operator does, that is used to sort of the SNMP style of getting data, or has alerting systems that are built a certain way with certain assumptions about the data. So to insulate them from these changes as we introduce them, the collectors can provide a caching layer with a variety of interfaces that allow upstream systems to keep doing monitoring the way that they're doing if they need to, but also allow new monitoring systems or new control loops to take advantage of both the real-time and triggered data that we're providing this way.
Yeah, on this slide, I love that. I love that picture too. By the way, are any network vendors? A lot of us in here, we don't clearly build our own equipment and write our own software stacks, if you will. Are any vendors supporting the gRPC, software that you can talk of?
Yes, you may see some very soon. So that's part of this effort. So, I said that we're collaborating with industry here. So the industry isn't just operators that we're collaborating with, it's also vendors closely. So we're trying to drive this agenda with vendors, and we've had a lot of great collaboration with.
Yeah, it was a serious question. I expect OpenConfig support and data modeling, but I hadn't heard of like gRPC support on again, equipment coming from the traditional.
I'm sorry, I didn't mean to give a tongue-in-cheek answer. Yes, I mean, the answer to your question is yes. We're working closely with vendors to try to get this support happening.
Cool.
This is, I think I mentioned all of this, in particular the thing about, introducing new transport protocols to deliver this data. We have this goal that we've stated publicly to get SNMP out of our network by the end of next year, essentially by 2017. So we want to have a network that's fully using streaming telemetry, not using SNMP anywhere. And so I think it's a pretty aggressive goal, but we've made a good amount of progress with vendors. I think you'll see announcements, over the next several weeks even, that gives us some cause for optimism. I mean, one of the other things I'll mention on this slide, I think Matt also alluded to this. This notion of being able to observe what the network is doing, other than to just go and scrape configurations is really key. And so having this streaming channel to get network operational state back enables that, right? We can observe the network state through that stream. I mean, even when I push a configuration, if I want to know if the network is now behaving according to that configuration, I can just view the operational state. I don't need to go, I don't want to have to go and look, oh, did the configuration actually land on the device properly or not? That's not the way to check what the network is doing.
Yeah.
And telemetry, by the way, is evolving towards a model-driven world in steps, right? It's, again, not going to happen overnight. Our first step with working with vendors has been to change from a pull to a push model, right? Start actually pushing data off devices. It might be in some proprietary model or data format. It might be over some proprietary channel or transport. But the first step is to just get the sort of high-priority data items off of the device in a streaming fashion. And the second step is then to introduce additional coverage of the data. So in step one, we don't have all the data we need. We might have just those high priority things. But as we evolve this solution, we start to get the right transport protocol, gRPC, as you're asking. We start to get more of the data covered, but it may still be based on a proprietary data model. And then in the last step is when we try to put all these things together. And this step isn't as far off as you might think. I mean, we're talking about maybe 2 or 3 quarters we're going to start seeing this stuff in actual releases from some vendors. So this would be gRPC transport with a common schema, a common data model over which that data is delivered back.
I will say I've been doing a lot of work with the legacy devices, and shout out to Google for TextFSM, Python library to get JSON data out of CLI text-based data, and it's been a great tool to use. So thank you.
I'll relay your thanks. Yes, I wish I could claim responsibility.
What about gRPC is more conducive to? Is because RPC, I presume it's an RPC. What makes gRPC more conducive to the streaming model than XML RPC or NETCONF?
So I actually have a slide on that, but I won't go all the way there.
That's
because I put it in the backup. So I'll just talk a little bit about it. So gRPC is built on HTTP2, which came out of Speedy, which is something that Google brought to the IETF, and it got standardized in the IETF as HTTP2. HTTP2 has bidirectional streaming support built in. It's got stream multiplexing built in, so you can send multiple disjoint streams on the same TCP connection. You can push from servers without having to make a request first, so it's got streaming in both directions.
Right.
It's got binary framing, so it's a lot more efficient on the wire than the text-based formatting that we have with HTTP 1 or 1.0, 1.1. And then gRPC adds on top of that the RPC layer. So that's where you get the RPCs, the sort of call cancellation support, some of the reliability and security support. We have lots of implementation. So gRPC has now been open sourced by Google. So it's essentially the same thing that we use internally for our RPC layer in all of our services, right? And now we've made it available as gRPC with a bunch of language bindings for almost every language that you can think of. So there's code out there that you can use to quickly stand up an endpoint or a service.
That's really cool.
Yeah, grpc.io if you're interested is the website for it.
Okay.
Some folks get the impression that we're talking about different data models for telemetry and configuration, but the way that we're trying to build our data model is so that they actually contain both. So it's one data model that we're constructing in OpenConfig that contains both config and telemetry data. So the way we structure our data model, this is just a snapshot of a model for managing interfaces, right? So you have an interface, and underneath it you've got two containers, one for configuration data, so this is like read-write data, and then one for state data, which is read-only data. And we also have this notion of having the configuration data be part of the state, because we view operational state as consisting not just of things like counters and derived protocol statistics, but also the configuration of the device is part of its state. So we include that in the state, as well as all of these counters. So what this does is it allows you to treat operational state as a more of a holistic container of both config and derived state, what you traditionally think of as operational state. And it's structured in such a way that every branch of the model has these two containers, right? So it's very easy to write code that can look at the operational state that corresponds to some configuration that you have for almost any place in the model. So it makes it easy to write this code to relate the two, and it's got an explicit location in the data model. So as you start putting data models together, so Yang models are essentially tree-based models. I'll talk a little bit more about that, but you can't build your whole network with one data model. You've got to have a bunch of data models for different parts of the infrastructure. As you start to compose those, the tree paths aren't deterministic anymore, right? But by constructing the data models this way, we make the location of operational state in the model very explicit and very deterministic. And that's what we think is one of the advantages. This hasn't been that well received in the IETF because it's not so pretty. But if you're writing code and not reading it as a novel, it actually makes a lot more sense.
This slide alone improves upon SNMP by miles, because with SNMP it's not obvious where the differences between operational state and configuration state are.
Yeah.
And it's much more of a pain in the ass.
So again, I think, Matt, you touched a little bit on this. I mean, so now we want the NMS to basically act on the streaming view of the state, right? So I'm observing the behavior of the network through this state feed, and then I can push configuration. And if I need to compare for discrepancies, right, what I push down versus what the operational state is telling me, it's very easy to do a get on a particular interface or the whole set of interfaces and get the configuration and state data together, and then very easily compare the two, right? So we already have some code in several operators, not just us, that is exploiting this pattern, and we're just getting experience with it now. It seems to be working pretty well. So let me come to OpenConfig now for folks who don't know what it is. So it's not a standards group. It's not an open source project. It has no governance at all. It's a bunch of network engineers and architects who are really close to operations working together to build these data models, right? So our primary output is data models. We've decided to use Yang. Yang has a fair bit of, or its fair share of warts, but I think the traction that it has in the industry, both on the vendor side and also on the operator side, is significant, and it's worth exploiting and leveraging that. As I said, it's very informal. We didn't sign any papers. There's no CLAs. There's no lawyers. We have just a weekly call that we get together on to discuss things. We have a GitHub where we manage issues about the models. We'd still be sort of 1 year later trying to figure out how to set this thing up if we got lawyers and all involved, especially with large telcos. It would be impossible. We have our fair share of lawyers too. But we structure it like an open source project, right? All of our models are published on GitHub as code. We use a versioning system that's not sort of what Yang natively uses. We have our own semantic versioning convention that we use, that we've published, to try to make the models feel more like software, and you treat them more like software. The development priorities are driven completely by operators. So this group consists only of operators. All of our development is done sort of initially with just operators and network engineers, and then we go to our vendor partners and work with them on implementations. I'll show a little bit about what that process looks like. We've had lots of close and very fruitful engagements with vendors on this so far. I'll talk a little bit about the progress. We're also engaged with standards bodies. We're not ignoring them. I think to your point earlier about IETF, it's not so much the speed, I guess. I mean, it's a different perspective in that organization than the operator perspective. I don't think the operators are that well represented in IETF, in this space at least. And I think we are, by doing this work outside the IETF, but still communicating with IETF and publishing drafts in IETF, we're trying to keep a close connection without sort of drifting too far.
I am very interested in, since you put that there, how the models within OpenConfig, how those interoperate or don't with the extensive list of models that are present in OpenDaylight's MD-cell. How does that work?
Yeah, so OpenDaylight actually has started adopting some of the OpenConfig models for managing, like their BGP speaker implementation, for example. They have a way to manage this. But OpenConfig uses Yang models for a little bit different purpose, right? So all of the services, northbound APIs, even the protocols themselves, they write Yang models to describe them, right? They have so Yang has RPCs, which are essentially the way that you can define what a protocol message looks like in something like OpenFlow or any other protocol of your choice. So that's why OpenDaylight has 500 plus models, because everything in the system is defined as a Yang model.
Right.
It's really not. It's less used for kind of management and monitoring the way I think Yang was originally designed to be used. I mean, they found a good use case for it there. So I wouldn't say it relates that closely to their way of using Yang. But on the other hand, folks in OpenDaylight have started adopting our models because it gives them a vendor-neutral way to, say, configure their BGP.
Sure.
Or other services as they stand them up.
Do you know if that's their intention long-term, to sort of just keep up to date with those models?
Yeah, I think with whatever is relevant, right? So we have models for things that they don't support and vice versa. Sure. But I would hope so. I think we have pretty good collaboration with them so far.
Cool.
And the same thing is happening with other open source controllers like ONOS. We've had some discussions. They're still sort of getting out of the gates on this. There's a project in NTT to build a new BGP routing stack out of, from Go, using the Go language. I think they're using some code from Zebra, but largely from scratch. They're using OpenConfig, or at least providing an OpenConfig interface to their BGP speaker as well. So just a quick snapshot of our GitHub. It's not only Google people working on this. We have some other people also who are pretty active. Rob actually is really awesome. He's contributed a lot of code, a lot of models to this effort. He's at Jive Communications now. So this is just a list of the current snapshot of our publicly released models. So we have a private GitHub in which we do a lot of our development, and then as we're ready to sort of publish models, we push them out to this public repo so everyone can look at them and provide feedback. Who's involved in OpenConfig? So we're happy that we have a fairly wide spectrum of different kinds of operators. So we have sort of traditional telcos, your AT&Ts, BTs, Bell Canada, Deutsche Telekom, the Terrestream guys. We have some cable operators involved. And then we have some web scale guys, and I think all of these folks, not everyone is participating to the same degree, so I'll be very upfront about that, but I think everyone has the same set of goals and is participating in some way. Not everyone is writing models. A lot of them are just bringing their operational use cases with their network engineering teams, making sure that the models that we have actually support and represent their use cases. So the benefit of having different types of operators in OpenConfig is that the models we build are not just for web scale guys or just for telcos, right? They're actually meant to capture use cases across the spectrum. So we are not building least common denominator models by any means. So the first thing that someone thinks when we say vendor neutral is that, oh, it must be least common denominator. It's what every vendor supports. No, it is what is the most operationally useful set of things that we all need collectively. Yeah. And that's what we call the base model. If you want to add additional features, knobs, extensions, great, I'll show you how that looks. But those are all additional things that we're not really going after. We're trying to focus on the things that are key to all the operators' use. So it means it's not a watered down model. It has everything in there that you typically would need in a regular operation. So the development process, I think I've said most of this. We do a lot of the work with just operators. We actually review actual configs on our calls. So we bring some of the configs, we look at them, make sure that the model supports them, or try to go through examples of how we could use the model to represent that config. We develop a draft of the model, iterate on it, and then when we publish it, then we start working with vendors on how it can be implemented. And this involves basically talking to vendors about how they're going to be able to map what's in the model to what's in their native implementation. And it's not always straightforward, as you might imagine, right? So there's some give and take and back and forth, and if we need to change the model to sort of improve the implementability of the model, we'll do that if it makes sense operationally. So without sort of sacrificing what makes sense for operators, we're willing to work with vendors, on changing models if it makes it easier to implement. At the end of the day, our goal is to get native implementations on devices. So we published a bunch of models so far. This is just a a list of what we have going. In the case of BGP and routing policy, this is where we started. They're our most mature models. They are where you'll see the first implementations. They've also been adopted by IETF for standards track. So that's good news for vendors. It means that there's going to be likely one model, at least, that they will have to support initially in addition to their own native models. Then we have models for other routing sorts of things. MPLS and traffic engineering is key to a lot of operators here. Someone mentioned that they're interested in getting more information out of routing tables, so we have a model actually for RIB contents. We're working on one for FIB and LFIB. We also have a model for how you configure streaming telemetry on devices. So that requires configuration, setting up the subscriptions that you want, what are the data feeds or the paths of the data model that you want to receive at what frequency. We've also started doing models for optical transport, so we have a model for terminal optics as well. And then here's some things that we have in progress. Some tough ones here, right? Like QoS, for example, is going to be an interesting one to do because very different on every platform. Yeah. So it'll be interesting to see how that model comes together. I think some of the models I've seen so far kind of punt on this. They just say, okay, this will be a vendor-specific augmentation of the model where they'll define their knobs. But we want to do a little better than that. I think that doesn't really help us if everything is a vendor-specific thing.
Curious, when you say you want to be off the SNMP by 2017, is the answer then for you internally using OpenConfig data models? Or is it other proprietary APIs or what have you?
Yeah, so as I said, I think it'll be a stepwise thing, right? So we won't get to OpenConfig data models for telemetry on day one, but that is definitely where we're going. I think on day one, it's going to be proprietary model or schema for the data, but at least it's pushed or streamed to us, and then hopefully over gRPC. So I think in the time frame that we're talking about over next year, I doubt that all of the data that we get will be according to an OpenConfig model, but we'll start to see some of it at least, and then other parts will sort of evolve over time. But it does mean that we don't have to use SNMP, right? We'll have the devices pushing the key pieces of data to us. We will still keep SNMP around because I think someone else pointed out that there's always something that you need to go get from a device that may not be exposed with new APIs. What we're trying to do is insist that everything that we collect via SNMP is, of course, in the model, so that coverage is there. For vendor-specific things, there has to be a way to add those variables quickly to the model and to the implementation, so we can get those streamed if we need to. So the progress is pretty good. I think you'll see the first versions of streaming telemetry in released vendor products early next year. You'll see support for BGP and routing policy configuration using OpenConfig models on iOS XR from Cisco, from Junos, as well as from EOS on Arista. Other vendors are working on this also. They're not quite ready to announce their plans, but hopefully that's coming. We have implementations in progress for the OpenConfig interfaces model, for the MPLS and traffic engineering model. Those are sort of the top three that we started with, and then we'll move down the list as we go. And operational state models that we talked about are being delivered as part of the telemetry solution. So in addition to data models themselves, OpenConfig is doing a few other things. We've published a bunch of design patterns of how you actually model operational state based on what I showed you before. We've showed, how, or at least expressed requirements and given some proposals of how models need to be assembled together to be useful. So again, having a BGP model is not that useful. I also need all the other pieces of the device in order to manage the full device and the full service, right? A bunch of folks are working on tools to generate actual data instances from Yang models. So Rob at Jive has done actually a pretty extensive and impressive tool for Python language bindings for Yang models, which means that you can take your Yang model, generate Python classes from it, and then use those classes to fill in data instances that are validated as you fill them in, and then serialize them out to JSON to send them out to a device. So he's got a pretty complete solution. We've started building a Yang compiler for in Go. So if you want to use something that's not as a little bit more type safe than Python, let's say. Go is a good solution that a lot of shops are using these days, and so we're trying to provide some tooling in Go for Yang models as well. And then AT&T has published already actually some authoring tools for Yang models. So a bunch of operators are investing time and people in actually creating tooling around writing the models, using the models, creating data instances, and so on. This thing about extending OpenConfig models always comes up. How do you deal with platform specifics or vendor specific things? The nice thing about Yang that we didn't have in SNMP is that it's meant to be extended and programmatically so, right? So you can write something called an augmentation to a model that adds essentially nodes to the data tree. And you can add nodes as a vendor, so the vendor-specific augmentation. We could add nodes as an operator that are consumed by our own management system. And then you could also have deviations. So not every vendor on day one will support the full model. And what we ask them to do is actually write a deviation for the model that indicates programmatically which nodes of the model they don't support. So we could overlay that deviation on the base model, and then what comes out of it is actually what the model is that we can use with that device. I'm going to speed up a little bit. Yang and NETCONF, I don't want to spend too much time griping about this, but there are gripes to be made here. Yang and NETCONF were kind of developed side by side, and I think one of the things that we talked about earlier was the need to decouple the transport and encoding serialization from the actual model. I think that's something that's still a work in progress, at least from the ITF perspective, but we're very much on that point about Yang is useful in itself for modeling the data. What you do to serialize it and transport it can be different. The other thing is that, Yang models are written to be human and machine readable. We'd like to put more emphasis on the machine readability part of it. I wasn't entirely joking when I said some people really look at Yang models as, a piece of art that is to be read and enjoyed. It really is, that's not a useful way to think about it. They really need to be treated like software artifacts and versioned like that and so on.
So don't put it on the fridge?
Yeah. Yeah, with the magnet. It's not something your kids are going to do at school. We also published a proposal in ITF, this last ITF, on a registry for Yang models where people can get information about what the model does, what its dependencies are, what implementations are available. There's like 1,000 models available out there today. As a consumer or operator, if you want to use models that are there, you have no idea of figuring out what actually works that's out there, what the dependencies are they available to use. There has to be some kind of catalog registry around this that's distributed, federated. So we had a proposal for that that seems to be getting traction. A bunch of challenges. So I'm getting into the part of the talk where I'm just going to share a few observations from the year or so of work on this that we've done. It's hard to get away from CLIs, especially when we've talked to vendors about implementations, right? Our CLI looks like this, and you're asking us to model it like that. That takes some back and forth and some insistence on the part of operators. And I think vendors understand what we're trying to do, so we eventually get there. We do have cases where implementations are just so different that it's going to be pain for one vendor to implement it and maybe easy for someone else. And as operators, we're not trying to take sides between vendors because we have people in the group who use all different kinds of kit. Right, so there's no one sort of vendor that's represented. So what we do is try to pick the approach that makes the most sense operationally. How do we think about this when we operate our networks? And that's what we put in the model. And that may make life hard for one vendor versus another sometimes. We talked about models being for machines, not humans. What to leave out of the model has been a big discussion. I think the approach that vendors take to writing models is to reflect all the features that they support. They want to make sure you can use every last knob via the model on their device. But as operators, we don't use nearly all of those, and we don't care about them. It's not that they're not important. They could still be put in an extension model or some augmentation, but they shouldn't be in the base model. The biggest problem I think we have is this last point, is now that we're starting to get implementations back from vendors, how do we test that they're actually compliant? I mean, how do you write unit tests for the models that you can actually go and confirm that the implementation is correct? This is a tough problem that we're trying to work on now. One interesting thing is that we're not getting all the models on day one, so model coverage is evolving, right? So we are going to live in this hybrid world for a while where we have some vendor neutral models and some native models, and we need both the NMS systems, the management systems that we're writing, and the devices to be able to handle that hybrid world. So we need to be able to generate config that's partially open config and partially native, and the device needs to be able to accept config that's the same way. I think everyone is starting to realize that, because there's not going to be a flag day where we suddenly change from all vendor specific and proprietary to all vendor neutral, right? That's going to happen over some period of time. These models take a lot of time to write. I mean, the reason we're not going to have a flag day is because writing the models requires surveying all the implementations out there, looking at all the vendor requirements, trying to get consensus on what's in the model. It is a we've been working at a pretty fast clip, but it's still a lengthy process. And fortunately, I think among operators, getting to consensus has not been difficult so far. A lot of iterative development. These models are changing very rapidly. It means that, for a vendor, it's not an easy thing to say that, oh, by the way, here's the model that we want you to implement, and it's going to be changed next month. So they want to wait until their next release to be able to issue the support for the new model. But we need some decoupling of the standard software releases from vendor platforms and the clip at which models are being updated. And we've talked about tools and so on. A few industry takeaways, I think, for, again, observations before I wrap up. This is a new concept for vendors, right? This notion of supporting external models. I think a lot of vendors are moving towards model-driven APIs, but this notion of supporting an externally defined model is something that they're still getting their heads around, right? It requires new infrastructure for them to do the translations. Some vendors are doing a lot of investment in that infrastructure, which I think is the right thing because they'll see additional models coming down the pike. Some others have been slower to sort of figure out that they're going to need to invest in infrastructure that lets them do this. Most of the folks in the vendor community are building support for OpenConfig models as well as IETF models. They want to support the standard models that will show up in RFPs along with OpenConfig models. And the telemetry framework, as I said, is ongoing, but we should start seeing it in early 2016. So to wrap up, this isn't going to be easy. Some of you may be skeptical, maybe for a good reason. So OpenConfig has the risk of just turning into another SNMP, right, at the end of the day, where we have base models that no one really uses, like standard MIBs, and everything goes in an enterprise MIB or a proprietary extension. That is a danger, and I'll talk about some of the mitigations for these risks. We have the ongoing challenge of vendors not fully supporting it, right? There's a few vendors that we might remember or think of that like to embrace and extend things that are standard, right? So this may suffer the same fate. Or we have implementations that aren't really complete or they perform lousily. That's a risk here. We also have the risk that operators are just going to struggle to consume this stuff, right? It's new for a lot of operators, especially the traditional telco community that are used to relying on a lot of third-party software providers for this. So until that support shows up, they won't be able to consume this stuff. So those are all, I think, real challenges, and there are probably others that you can think of. But I think this also has a big payoff if we can pull it off, right? So, this problem about becoming another SNMP, what we're trying to do is really focus the development of these models from operators, right? So it means that hopefully operators will find them useful because they're the ones who are defining them. It's not something that's being defined for them by somebody else. And they're inherently extensible, so they're not like SNMP where you can't really extend an SNMP MIB very easily. As far as vendors, vendors, as I said, are moving towards this model-driven world already. We're trying to leverage some of the traction that we have with vendors in that space. We're being very insistent that we're going to include the requirement for support for OpenConfig models and streaming telemetry in every RFP. We won't introduce any new platforms into the network, and it's not just us, it's other operators that are saying that. I think one thing that we're helping vendors with is consolidating requirements across a whole bunch of their big customers, right? So they're not having to go and support a ton of different models. Here is a set of models that covers the use cases of all of these guys. This problem of operators not adopting it, I think what we're really trying to do there is just, as much demonstration and help that we can provide through reference implementations, tooling, open source. I know that not everyone is ready to consume open source, but I think if we can show operators how this can be used for specific use cases is the way that we can get traction and really get it more widely used with operators. So I'll just end by saying that we think this really has the opportunity to dramatically change the way we're doing network management, both from a monitoring point of view and configuration. All the talk we had earlier about wanting to live in a vendor-neutral world, there's no reason that I need to configure something like BGP or MPLS differently on all my devices, right? It is the same standard protocol everywhere, or that the data coming back from devices needs to be different. So we're trying to solve some of those problems with OpenConfig. It will take some time, but I think we've made a lot of progress in a short time. And if there's any questions, I'll be happy to take them.
Would you say that, based on the members slide you had earlier, this seems to be very service provider driven? Do you still see the model has applicability outside that service provider environment? Is that focus going to be there, or is it really going to be on what service providers want? And
yeah, it's kind of where we started and where we have we've gotten a lot of interest. We definitely want to get more large enterprise shops who are trying to do the same thing. So a lot of operators of all kinds of scale have the same goals at the end of the day, right? Around automation and simplification and monitoring their network. So I don't think the models are confined to service provider use cases only, and they're not intended to be. I get a lot of questions about, well, this is only for WAN. It's how does it apply to data center? So we do have things in the models for interface management, VLANs, L2, all the kinds of things that you typically have in the data center, including in addition to all the IP stuff that's there. So I think there's a good deal of applicability, but we would love to get more enterprise shops involved in this effort as well.
Right. I mean, because we don't have service provider SNMP right now. It's SNMP.
Yes.
Love it or hate it, it's ubiquitous, right?
Yeah.
And I would hate to see this go down that path where this becomes service provider OpenConfig and everyone else says, oh, well, we'll do something else.
I agree.
So I think it's absolutely critical that you have that broad availability and applicability that makes it adoptable in every market, if that's the path we're going to go down.
Yes, I agree completely. I mean, if you have suggestions on how we can do better sort of outreach to that group, we've talked to a few folks in financial services that have expressed interest. Some of the other, the eBays and Dropboxes and folks like that have similar initiatives going, but they're not necessarily intimately involved in this yet. But we're trying to get them on board.
Yeah, it would definitely be interesting to get some. You say financials, that gives me another little twitch, but cross-vertical support, because again, financials have a very, very specific, wild generalization. They tend to have a very specific set of needs, just as service providers do. So my view is that increasing that NASCAR slide of the participants to include a broader range is going to be fairly important. So
good feedback, thank you. Anybody else? Questions? Comments? Think this is a crazy idea? Should never do this?
It's necessary. I mean, I think the only thing I worry about is that it's impossible that all the vendors will be able to implement this. So we're still going to have to settle for, I think, a little bit of heterogeneity. But hopefully, I'm sure, as you're hoping, it will reach a certain point where enough support this that you have broad choice within that pool. Yeah, you might have to leave out, some old version of iOS, but at the very least, you can support everything that's in your infrastructure. I just don't. I don't know if it's going to get to that point. I hope it does.
Yeah, I think as more operators start using it, you will see them demanding the support from their vendors, and that's how the coverage will improve, right? So as you said, we're starting with the things that we care about, not just we Google, but we in OpenConfig. So the vendors you'd all expect to see are there, but the other vendors, are watching, and we've talked to them. They come and talk to us, and they want to know sort of how they can get involved and so on. But until their customers start asking for it, they're not going to have a lot of incentive to support it. So, I think that's going to be key, right? As we make it more consumable by operators, they will start asking for the support when they see the advantages that they can get.
So what's the roadmap like in terms of just, you hit the models on there, but models cross-referenced with vendor platforms?
Yeah, so I'm trying not to say too much publicly about what vendors' roadmaps are, because they're hopefully going to do some of that themselves. So there's been public statements about, I wouldn't call them roadmaps, but at least intent to support, and even which release will support the first set of OpenConfig models from the 3 vendors I mentioned on the slide. But we are trying to push them to actually provide roadmaps of when they will provide what sort of support, including the telemetry pieces. So hopefully you'll see that soon.
And is your feeling that the vast majority of them are really putting in the effort to make it a pure OpenConfig model compliant implementation, or hey, here's some of the stuff that we managed to cobble together, and then also some of our proprietary extensions because our software isn't great?
They will always want to do proprietary extensions, but we're pretty insistent that the base model is the base model, and if you can't support it, you have to write a deviation. We're not going to wrap it in an if feature. Like in Yang, you can actually say this is a feature of the system.
Right.
But if it's in the base model, we're making a statement that this is a required thing that operators need you to support, and if you don't have it, write a deviation so that it becomes something that is clearly a gap in your features.
Yeah, I mean to me that's like the biggest thing for this to not become the new SNMP. It's like the whole point of this is to simplify things from an operational perspective. So what would totally defeat the purpose is that you implement your own Snowflake config and make me think about that. right? Prevent me from having, because like again, that translation is being moved into the edge.
Yep.
And if you deviate from that it's just getting moved back up.
Yeah, absolutely. I mean, that's why we're trying to manage this very closely. I mean, this thing about vendor augmentations, we don't want to discourage vendors from, exposing all their latest and greatest knobs, right? So there is a mechanism to do that.
Yeah.
And some customers will need to use those knobs. At Google, we probably can get away with not using a lot of vendor-specific stuff, but we have hardware features on a device that we do need to use, and those will be necessarily in a vendor-specific augmentation.
Okay.
Ed, you had a question?
Yeah, is there any intermediate stage that this goes in where, let's say across the board, you're not going to get a feature release for older downstream, someone's going to write some sort of proxy configuration that does OpenConfig on one side and talks whatever vendor-specific implementation. At that point, you don't care as long as you're getting the right data back on the OpenConfig side and the right state information back, but it still is a halfway point, right?
So we are doing that now, right? Because today we don't have full native model support, as I said. And even on the telemetry side, we're able to do translations in that collector, right, that help us provide a uniform model upstream, but then can deal with...
So is the expectation that the manufacturers are going to publish and provide that, or is it the expectations that the operators are going to build that? Because that's...
Well, operators have been doing it for a long time. We're trying to get the device vendors to do that, the implementers, right? So I think, as you said, we will have to live in this halfway house for a little bit of time until we get full native support of the models we need. And to do that, what we've been insisting on internally is building a full vendor neutral layer, right? So that we will do translations from that layer into specific devices today, but tomorrow we want to get rid of all those translations. And so whatever comes down to that layer just gets sent directly to devices. But we necessarily have to live in this sort of hybrid world for a while. Okay, the screen has turned red, which means I have 30 seconds left. It looks like.
If we just write temporary on the translation boxes, we know they'll be there forever, so it's safe.
That is a danger, by the way. I mean, that's why we really have to push for native implementations if we want to get out of that. I mean, there's still value to having that vendor neutral layer because, again, you've insulated a lot of upstream tooling. But you still then have the problem of maintaining all of the downstream drivers and so on.
Right.
So we haven't fully solved the problem if we get stuck there.
It's a huge change, and it's positive. It's a positive direction, but it is a big change. So.